Hey guys, so we just learned about gradient in the previous videos. So now we'll be specifically tackling the distance time graphs and we'll see what additional information we can get from the distance time graph apart from the observational data that we can collect with about the distance, obviously. So we have a distance time graph. So you would ask me, Adil, why did you teach us gradients? I mean, it's not required here, but you are wrong, guys, because it is a very essential part of distance. For a given distance time graph or S by T graph, the gradient of a line gives you the velocity of the object at that point. So if you have a graph and so the first thing from a graph, if you have a graph, you can collect is the information about distance or displacement. It's the same thing. Distance, it's displacement. You can say distance time graph or displacement time graph. It's the same thing. For in this case, in the case of graphs, we generally use displacement. I'm sorry, I used distance here. Information about displacement, and we'll see how we can get the information about velocity. So let's just take an example here. Let's say we have a graph here. Alright, this is the graph. This is the S by T graph. Okay, this is, let's say, 6 meters from our previous case. This we know is 2 seconds. This we know is 4 seconds. And this again is 0. Okay, so this origin point is 0. Now first of all, if I ask you describe the motion in terms of distance, of displacement, you can tell me that this is a car that was standing at point O, okay, point 0. There was a mark of 0 where the car was standing. So you can tell me this was a car standing at point O at 2 seconds, time 2 seconds. This point had moved a distance of 6 meters. Till the 4th second, as in the time was moving, but the car was not. The car still had the same displacement from the origin. So even after 4 seconds, this should be here, the car was at the same point. Let's say point P3, and the car is point P2 here. It's at the same point. It's at the same distance from the origin. And at time t is equal to, let's say, 6 seconds, the car moved back to its original position at zeros. So it covered the 6 meters back again. So this is the information I can get about the distance, and each and every distance is clear to me. But what about the velocity of the car? Remember that from a displacement time graph, we can always get information about velocity. So the velocity is the gradient of a displacement time graph. So we know that this line, and this line, they all have different gradients. So we will tackle them each one by one. This is line A, this is line B, this is line C. From our study and interpretation of gradient, I can tell you that this is a positive gradient because it's increasing like this. We know that. If it's getting from a bottom point, it's going to a top point. Let's see, let's find out the gradient of this line, the section A. So y2 minus y1 divided by x2 minus x1. So the point here, the first point I would be taking for A is 0 and 0, this one, and this would be 2 and 6. Let's say this one is point 2, and this was in point 1. So this would become 6 minus 0 divided by 2 minus 0. So this means 3. Gradient is 3. This means that the car is traveling at a velocity of 3 meters per second. And since the line is straight, it will have a uniform gradient. This means that the car is moving with a uniform velocity. At every point, the gradient would be 3 meters per second. This means that till time t is equals to 2 seconds, the car moved with a velocity, a uniform velocity of 3 meters per second. Let's see for section B. Let's see for this one. I can tell you from the interpretation that the gradient will be 0 since there is no slope of the line. There is no line. If you sit over here, you will not slide. So there's no slope. Let's just find out again. Let's just see. Let's take this one point on the line and this one point on the line. One point is 2 and 6. The other point is 4 and 6. Let's see. y2 minus y1. This would simply become 6 minus 6 over 4 minus 2. This would become 0 over 2, which means 0. This shows us that the car has a 0 velocity now. The velocity of the car is 0, which we predicted from the distance that the car would have 0 velocity because it didn't move any distance. It was standing there till 4 seconds. So throughout this line, the gradient is uniform and the velocity is 0. The car is not moving anywhere. So we have the information of velocity of this section. Now for this section, part C. Let's see. I don't have much space here, but I want to do it here. So let me just erase it. Let me just erase this thing from here. Okay. Let me just talk about point C. From our interpretation, I can tell you that the graph will have a negative gradient. Let's see. This point on this line is 4, 6, easily achievable. 4 on the x-axis, 6 on the y-axis, and this point is 6 and 0. 6 on the x-axis, 0 on the y-axis. Now let's find out the gradient. y2 minus y1, 0 minus 6 divided by x2 minus x1, 6 minus 4. This would give me minus 6 over 2, a gradient of minus 3, which means that throughout this line, since this line is uniform, at every point the gradient would be minus 3. I can take any of these points and the answer would be minus 3, showing us that the car now at this point it had a velocity of minus 3 meters per second. A velocity of minus 3 meters per second means it doesn't make sense. I mean, what is a velocity of minus 3 meters per second? But the sign shows the direction, and velocity has a direction of importance. So minus 3 meters per second shows that if it was at this point, let's say this is O and this is 6 meters. If it was at this point, it moved back. First, it was moving in this direction, in the positive direction, so the velocity was 3 meters per second. Now it's moving backwards. It has changed its direction. It has reversed its direction. It's reversing now. So it's in this direction with a velocity of 3 meters per second. So now we can find out the information about distance and velocity from this. Let me take another example and you will be clear about this. Another graph, just any random graph. Let's say this is the graph here. Let's say we have these given. Okay, so this is a displacement time graph. Meters, t in seconds. So this has been given to us. We just have to find out the information that we can gather. This is 0. Let's say this mark here is 3. This mark, the peak is 6. This mark again is 3 at a height of 3, and this is 0. This time is, let's say, 3 seconds. This time for this peak is, let's say, 5 seconds. This time it's 7 seconds. This time, let's say it's 10 seconds. And this time it's 12 seconds. So what is happening? Now first, the observational part. From the observation, we can only tell about the distance. So this was the car standing at O first. Okay, this was the car standing at O. Now at t is equals to 3 seconds, the car has moved a distance of 3 meters. Since we can see it's at 3. At 5 seconds, the car moved a distance of 6 from the origin. That means an additional 3 meters. After that, at t is equals to 7, the car is at 3 meters again. This means at t is equals to 7 seconds, the car is back again at the same position. That means it has reversed. This is my prediction. I don't know as yet, but yes, it makes sense that it is at 3 again. Then till t is equals to 10 seconds, the distance remains 3. This means it hasn't moved. It is stationary here. And from here, t is equals to 12, it comes back at t is equals to 12 to its origin position at s is equals to 0 meters. So this is what I can make of the observation. This was the path. Did this, then somehow came back here, and now he's back here again at the same point again. So this is the kind of the observation that we can make. But we can also talk about the velocity. Now talking about the velocity here, we'll have to divide this in sections. Since the gradient is not uniform, gradient for this line is different than this line, and this line, and this line, and this line. All of the lines have different gradients. So we will label this as A, this is B, this is C, this is D, this is E. The velocity at A. Let's find out the gradient at A. What is happening? So let's take this point, this 1 point, and this 1 point. 1 point would be 0 and 0. You all know this now. 3 and 3. This is the other point. Gradient is y2 minus y1 over x2 minus x1. So this would be 3 minus 0 divided by 3 minus 0, which is 1. So it is a positive gradient. I can expect a positive gradient because it's going from bottom to top. So this means the velocity throughout this point till it reached here, its velocity was 1 meters per second. So a constant velocity of 1 meters per second in this point. Since at every point the line is straight, so at every point, using any point, we'd get the same gradient. This means a uniform velocity. Okay, so this is a uniform velocity. Now let's talk about B, velocity at B. So let's take 2 points. One of the point can be 3 and 3. The other can be 5 and 6. So again, y2 minus y1 over x2 minus x1, 6 minus 3 divided by 5 minus 3. This would give me 3 over 2 meters per second. Again, the gradient is positive, which I can clearly expect from here. So this means 1.5 meters per second. A constant velocity of 1.5 meters per second from this time to this time. It was moving at the same velocity throughout the journey, throughout these two intervals. Now part C, velocity at part C. Here we can expect a negative gradient because it's going from top to bottom. So let's see, this is 1 point, 5 and 6, the other point is 7 and 3. So 5 and 6, the other point is 7 and 3. This makes it 3 minus 6, y2 minus y1 over corresponding x2 minus x1, 7 minus 5. This makes it minus 3 over 2. This is a minus 1.5. Now I told you what a minus 1.5 meters per second means, that it is having the same velocity, 1.5 meters per second throughout, but in the opposite direction. First it was moving like this, now it's moving like this. So The direction has changed, because of which this minus sign has been introduced. Now let's talk about velocity at point t. Since it's a straight line, we can safely say that the gradient is 0. So the velocity is 0. And we expected this, that it would stay here from t is equal to 7 to t is equal to 10 seconds, which means it will have a 0 velocity. It's just at stationary. So we can say this. And from E velocity, to find velocity at point E, we can just take 2 points. One would be 12 and 0, the other would be 10 and 3. So 12 and 0, and the other is 10 and 3. I hope you can see this. Now I'm just finding the gradient. This would be, I can say that this is a negative gradient because it's going from top to bottom. 3 minus 0 divided by 10 minus 12. Again, this is a minus 3 over 2 meters per second, which means it is going with a magnitude of 1.5 meters per second. It has a velocity of 1.5 meters per second, but the minus sign tells me that it is in the opposite direction. It is now moving in the opposite direction. So guys, this is how you understand a displacement time graph. Remember that a displacement time graph gives you, through observation, the distance or the displacement, and by calculation, by using gradient, you can find the velocity at specific points. And for a straight line, the velocity is constant or uniform, or the gradient is constant. So it will have the same velocity throughout that region of straight line. But if the straight line changes its gradient, then its velocity also changes. So thanks for watching, guys, and stay tuned.